Hello, today we're going to be talking about critical numbers. Critical numbers are just when you're trying to find a derivative and then you set it equal to zero. And later on, you'll see why you'd want to do that. There's some application stuff you can get from it. It's going to be the point of a lot of it. But for now, we're just going to practice doing it because that's kind of the key for a lot of this. So I'm going to put it up here just so you don't forget that if we set the f prime of x equal to 0, then we will get a critical number. And we use those critical numbers for numerous things. But for now, let's do a few examples and you can see what I mean. So if we wanted to, let's just say we had a standard function. So let's start with a polynomial. It's always easiest to show you. Let's say x to the fourth minus maybe 4x squared, let's just say, okay? So the first thing you want to do is you want to take the derivative of this. So let's have the derivative first. So f prime of x, we bring the 4 down for the first one, decrease the power by 1, we'll get 4x cubed, and then we're going to carry over the constant 4, we're going to bring down the 2, we're going to decrease the power by 1, we get 2x, and now we just have to simplify this. So f prime of x, the first part will stay the same. We'll have the 4x cubed. And now 4 times 2, though, is negative 8x. Okay, so what do we do now? Well, as I said, to find these critical numbers, we just have to set the derivative to 0. So let's do that. So we'll set the derivative to 0. Okay, so first let's rewrite this. Okay, so we can rewrite this as 4x cubed minus 8x equal to 0. And when you get rather good at this, you can kind of just go from this step and just start doing stuff. But when you're first starting out, good to rewrite it first. So what can we do to get each x basically set to 0? So usually you'll have to factor something. So before we factor, though, can we take something out? It looks like we can. We can take out an x. We can also take out a 4. So we can take out a 4x. So if we take 4x from this, we'll just get that this is going to be x squared, because 4x times x squared gives you 4x cubed. We take a 4x out of this, we'll have just a minus 2, because 4x times 2 is negative 8x. And again, this is still equal to 0. And again, when you get really good at this, you can just sort of imagine the 0 if you get lazy, but technically the 0 should always be there. So to solve for this, we have to understand that we can break this up into two parts in our mind and then solve it from there. So we know that we're going to have this 4x equals to 0, and we also have this x squared minus 2. So whenever we have a 4x equal to 0, we'll have that it's just equal to 0. And the reason is because if we set each factor equal to 0, so the 4x equals to 0, and also the x squared minus 2 equal to 0, if we have the first one, we divide by 4. Well, if we divide by anything, you'll just get that x is equal to 0. 0 by 4 is just 0. And you're going to find that a lot. So whenever you have a single x term, no matter what's really happening to it, you'll always just get that it equals to 0. This one's a little different, though. So we will add 2. We'll get x squared is equal to 2. Then we can take the square root of it, and we'll get that x is equal to plus or minus 2. You can do it this way, or you could have just known that if we factor a perfect square, you'll get this as well. But either way, same answer. And these would be your critical numbers. So as soon as you get that x is equal to a certain number, this is what it is. Oh, and I apologize. I should have kept the square root there because it doesn't turn into 2. Okay, so let's try another one while we're ahead. So let's see something little simpler, and I can tell you the reason why I make it simpler after. So if we just have x cubed, well, let's find the critical numbers there. So if we bring down the 3 and we decrease the power, that's 3x squared. Then we have the derivative taken, we set it to 0. Well, we have the 3x squared equals to 0. We just have to divide by 3. We have x squared equals to 0 still, like I told you. And then if we square root both sides, we still have that x is equal to 0. So I did this one to show you that if they have some sort of term and it's just equal to 0, at the end, like just the x's alone, and there's just multiplication and division with the x, it won't change the fact that it's still going to be equaling just to 0. And you might be wondering, like, what do these critical numbers really mean? So before I move on to a few examples, I just want to show you. So if we wanted to know the graph of this, well, we know that this graph, like it's a polynomial and we have an even graph. We know from pre-calculus it'll look a little something like this. Not exactly, but something similar to this. So we know that it looks like this. And what the critical numbers are going to tell you, they're going to tell you the dips and hills, basically the mins and maxes relative to the graph. So critical numbers will give you what are called relative mins and maxes in some cases if you want to find that. And you'll learn more about that later on. Okay, but if you look at this, we have points here and here and here. These are mins and maxes. Well, this is the 0. Here's the negative root 2. Here's the root 2. So basically, critical numbers are telling you information about a graph of the original function, and that's going to be helpful later when we want to find other things. But for now, I just wanted to show you that's what it is, and it's very similar here. We have a very standard cubic graph, and at 0 here, this is where the critical number is. So I just wanted to show you that really quickly. Okay, so I'm going to give you one more polynomial example. So let's just say we had something like 2x squared, let's just say plus 4x, and we wanted to find the critical numbers. Well, to do that, we would just take the derivative. So if we keep the constant here, then we bring down the 2, we decrease the power by 1, that's just 2x. Then if we know the derivative of x is 1, then it's 4 times 1. Then we have f prime of x equals to 2 times 2x, which is 4x plus 4. And we want to set that to 0. So we'll just rewrite it out. So 4x plus 4 equals to 0. We'll subtract by 4. We have 4x equals to negative 4. Then we divide by 4. And then x is equal to negative 1. Now that we have that, this is our critical number. So even though it's a new topic, it's not too bad from your already derivative rules. So I'm going to come back with something else to show you that it could be anything. Okay, welcome back. I just want to give you one last example to show you that they can give you things that are a bit harder at times, and they will kind of give you that later on. The same process kind of applies. So if we had like something like 4x over x squared plus 1, how would we do this? Well, what we'd have to do is we take the derivative of it with the quotient rule. So we know that this is f and this is g, but the same rule applies. So we'd have the g times the f prime minus f times g prime over g squared. So let's do that then. So the f prime of x would be equal to our g, so our x squared plus 1 multiplied by our f prime, which would be 4x. So 4 times 1, the derivative of x is 1, so just 4. Then we would subtract f, so 4x, and then we'd multiply by the g prime, so x squared would be 2x, and then that's a constant, so it's just 0, and that would be all over this one squared, so x squared plus 1 squared. Then we just simplify everything the best we can. So we would just we distribute this 4, and we distribute this one as well. So 4 times x squared, that's 4x squared. 4 times 1, that would be 4. We keep the minus here, and we're going to distribute it after. So 2 times 4x and 2x, that gives you 8x squared. Then we'll just kind of carry over the bottom part, so x squared plus 1 squared. Then we would just have to combine the last thing. So we have a 4x squared, and this would turn into a negative x squared. So then it just turns into a negative 4x squared, and then we keep the 4 the same, and this is all over x squared plus 1 squared. And we want to set this equal to 0. But you might be asking, how do we set this equal to 0? Well, usually what teachers will ask you to do is you're going to set the top part of the fraction and the bottom part of the fraction both equal to 0. And that's just how you want to do it. So for the first one, you would have negative 4x squared plus 4 equals to 0. And this one, you would have basically just the x squared plus 1 squared equals to 0. Okay? So what you want to do and understand is, let's just do this one first because we've kind of done similar ones before. So we would subtract negative 4, and negative 4x squared equals to negative 4. Then we would divide by negative 4. So this just turns into 1. So x squared is equal to 1. Then we take the square root of 1. And then, of course, that's just going to be plus or minus 1. So the first one is that x is plus or minus 1. And let me quickly make that better. And then for this one though, the interesting part is here, you'll be able to see it quicker, but we actually can't get a number from this, a real number, because if you notice, we take a square root, the first step to get to x, then we have this x squared plus 1 equals to 0. Now the issue is that if we subtract the 1, we'll have x squared is equal to negative 1. We take the square root, but oh no, this is a negative 1 in a square root, which means we'll get I, but we can't use I for our critical numbers. They won't exist on the graph, so we just end up sort of crossing this one out as not being a critical number, which means that our answers would be x equals to plus or minus 1. So I just wanted to show you that this is an intro to critical numbers. Not too bad to do. It just takes some getting used to solving for 0 after taking the derivative. But this is important to get good at because this is pretty much what the applications of derivatives will be the basis of. Thanks for watching. Hope this helped.